Welcome everyone to today's Explainer. I am absolutely thrilled to be your guide as we jump into a really fascinating journey today. We're going to take a scientific mystery, something that might literally trick your own eyes and uncover a profound truth about how our entire universe operates. We are talking about the law of conservation of mass, and, as we'll see, we're also going to explore how the source material uses this scientific rule to reveal the blueprint of a constant creator. So grab your notebooks and let's get started.
Okay, let's dive right in with the question. You've all seen a campfire, right? You start with these massive, incredibly heavy wooden logs. You burn them for a few hours, and the next morning, what's actually left? Just a tiny, lightweight pile of ash. So, where does the rest of it go? Does the wood just magically vanish into absolutely nothing? I mean, our eyes tell us that the matter has been destroyed, but science tells us a completely different story.
Here's our roadmap for today's Explainer. We'll be looking at the Great Disappearing Act, what is the law, the closed system secret, real-world science examples, the constant creator, and we'll wrap up with education, morality, and peace.
Let's start with Section 1, the Great Disappearing Act.
Here's the big idea for today. Matter is never created or destroyed in a chemical reaction, it simply changes form. This is really the absolute heart of what we're talking about. In everyday life, things don't just disappear into the void. Think about baking bread in your oven, or, putting fuel in a car. The matter you start with undergoes an amazing transformation. It turns into something entirely different. But the total amount of stuff, the total amount of actual matter stays exactly the same. It's kind of like the ultimate shapeshifter.
Moving right along to Section 2, what is the law?
So, let's anchor these everyday observations into hard science. The law of conservation of mass states, in a closed system, matter is neither created nor destroyed during a chemical reaction. I really want you to burn this definition into your memory. It is one of the most important foundational principles in all of science. It's the absolute rule that nothing comes from nothing and nothing just vanishes.
Now, to really master this law, we need to know the scientific lingo. On the left side, we have our reactants. These are basically your ingredients. It's the mass of the materials you start with. Then, on the right, we have the products, and that's exactly what it sounds like, what you end up with after the reaction happens. Because of the law we just talked about, the mass of the reactants must perfectly equal the mass of the products. It's like a perfect, unbreakable cosmic scale.
Which brings us to Section 3, the closed system secret.
So, if the reactants always equal the products, why does that campfire ash weigh so much less than the log? Well, it all comes down to a closed system. This is a controlled environment where no matter enters or leaves during a reaction. And this is the secret to actually proving the law. If scientists want to track exactly where the matter goes, they can't let any of those invisible gases escape into the room. They literally have to trap everything.
Let's tackle a classic homework question to show how this works. If you burn a piece of paper in the open air, the smoke and gases just float away, right? Your eyes are totally tricked into thinking mass is lost because the ash that's left over is so light. But if you burn that exact same paper inside a completely sealed glass jar, which is our closed system, all the ashes, the invisible gases, and the heat energy are trapped inside. If you weigh that jar before and after, the mass stays exactly the same. The open system tricks us, but the closed system proves the law for sure.
Let's look at Section 4, real-world science examples. Let's step out of the textbook and into the kitchen. Think about baking bread. First, our reactants, flour, water, yeast, and sugar. Next, we bake that mixture, which triggers a chemical reaction. Finally, we get our products, that delicious loaf of bread, plus water vapor and carbon dioxide gas. Now, even though the gas floats away in your kitchen, if we could somehow bake this in a giant closed system and collect all those invisible gases, the total mass of those products would be identical to the heavy dough we started with. No way around it.
Here's a second example, the sealed reaction. You've probably made a science fair volcano using vinegar and baking soda, right? It bubbles and fizzes like crazy. Well, those bubbles are actually carbon dioxide gas escaping. If we conduct this exact same experiment inside a sealed flask, trapping all those fizzing bubbles, the mass before the reaction perfectly equals the mass after. The atoms didn't disappear, they just rearranged themselves into a completely new form.
Or consider a candle in a jar. When you light a candle, the wax slowly disappears. Or so it seems. But actually, as it burns, it reacts with oxygen to produce invisible gases and soot. If you do this inside a sealed jar, the final products, the leftover wax, the soot, and the new gases, weigh the exact same as the original candle and the oxygen combined. See, even fire doesn't destroy matter. Nothing is magically added and nothing is ever lost.
So why do we actually care about any of this? Well, because matter is perfectly conserved, engineers can mathematically predict exactly how much product will form in a reaction. It's absolutely crucial. It allows us to design safe chemical processes for manufacturing, and it helps environmental scientists understand massive natural cycles, like how water and carbon move through our planet without ever truly being lost. It is the ultimate tool for scientific accuracy. Now let's move to Section 5, the constant creator.
At this point, our source material shifts perspective a bit to look at who might have written these unbreakable rules. The text connects this scientific principle to Ecclesiastes 3:15, which says, "Whatever is has already been, and what will be has been before, and God will call the past to account." Think about the profound weight of those words in relation to what we just learned. Matter isn't being spontaneously created or permanently deleted. It has been before, just in a different form.
The curriculum draws a really interesting parallel here. It states that just as God's creation remains constant in his plan, matter itself is constant. According to the text, the unchangeable, incredibly predictable mathematical nature of chemistry isn't just an accident. It presents this as a direct reflection of a constant creator. The argument being made is that the universe operates on these reliable laws because it was designed by a reliable God. By understanding the science, the source suggests, you're actually uncovering the constancy of that design.
Finally, Section 6, Education, Morality, and Peace.
Here, we're shifting from what we've learned in our heads to how the source says it applies to our character. The Heroesmart Academy Godly Learners series presents a core philosophy: education without morality will hurt. The text argues that just being highly educated or understanding complex chemistry lacks true purpose without a moral compass. The premise is basically that if someone continues to make bad choices, all that education will ultimately just lead to pain. True learning, according to the source, intertwines biblical morality with academic education.
To support this idea, the curriculum points to Romans 8:6-7, which promises peace of mind to everyone who keeps their minds spiritual. The idea presented here is that when educated minds align with spiritual morality, the result isn't just intelligence, it's actual peace, and that is defined by the text as the experience of true, holistic learning. Which brings us to a final question from today's explainer. You've just learned the unbreakable rules of the universe. You know that matter doesn't just disappear, it transforms. So how will you use your education to make good moral choices? The challenge here is to not just be smart, but to be wise. To transform your knowledge into positive action. Thank you so much for joining me today. Keep those minds curious, and I'll see you next time.